So good morning, everybody. How is everybody doing? I hope you had a great start into Spring 1. My name is Peter Niederwieser. I'm a developer and consultant for Gradleware, which is the company behind the Gradle build tool. And today I'm going to talk to you about building a continuous delivery pipeline with Jenkins and Gradle. Now, before I get started, I would like to do a quick show of hands. Who of you is currently using Jenkins? Wow, pretty much everyone in the room. Who of you is using Gradle? Wow, lots of people as well. Anyone looking into Gradle? Wow. Okay, so you've come to the right talk. This is going to be quite a practical talk. So I'm trying to show you one way to get started building your own delivery pipeline with Gradle and Jenkins. This talk is not very prescriptive. There are many ways to do it. I'm going to show one of them. It's not the most sophisticated pipeline that we are going to build, but hopefully it will give you lots of ideas and tips how you can build out your own pipeline. So who of you has had this situation? I certainly had it. So this is exactly what we try to avoid with continuous delivery. We want to make shipping software easy. We don't want to make it painful. I mean, I remember a few years back, this was me. And I was like totally sure I would ship the product this Friday afternoon. Everything was looking good. I looked up the recipe on the wiki. It was this simple 87 steps that I had to follow, and sure, everything would go well. And then as time progressed, suddenly some of the information was outdated and it didn't go so well. And then I started to order some pizza and call home. I might not come home tonight. And you've probably been there. I certainly have been. And this is what we are trying to avoid. Instead, we want to have this. We want to ship our software regularly, frequently, in an automated fashion. We want to train it all the time so that we can do it whenever we would like to. And we want to do it in a highly reliable way, like your express delivery. So let me start with a few principles of continuous delivery. So first of all is we have to be in the mindset that every commit can result in a release, every single commit. Now, we might not actually ship every single commit because that might be someone else's decision, but every commit, our goal should be that every commit is fit for a release. That means that we need to automate everything. If each commit, and hopefully we're doing lots of commits each and every day, if each commit can result in a release, then we have to do everything that we need to do for a release with each commit or for each commit. And that's only possible if we try to automate everything that we can automate. So we invest upfront in automation to make it a really easy and repeatable process. Take the pain out of this manual wiki process we had. As part of this automation, it's really important that we have automated tests on different levels, at least unit tests and acceptance tests, because every commit might become a release, and so we need to know whether a commit is fit for the purpose. So we need to stop it before we ship it if it's not good enough. And automated tests help with that. And then we need to redefine what done means. So, back in the times, maybe 20, 30 years ago, I still remember I had a coworker who was very happy one day. He said, my code is, what did he say, compile clean. My code is compile clean, achieved my goal of the day. And we were looking like young developers, were looking at him, what does he mean? I mean, my code compiles all the time, right? And then we learned, okay, you need to do more than that. Every commit should pass its tests. But now we need to really take the next step, and every commit, we have the aim that every commit is releasable. And that typically means more than just passing the tests. We also need documentation and lots of other things that we need to put together so that we can really ship something. So we need this new mindset of what done means. Okay, and then we want to, our build process will be made up of many pieces, and we want to align them in one build pipeline, and we send every commit through that build pipeline. If it's not good enough, we'll stop it somewhere in between. We'll put some checks in between and stop a commit that's not good. And every commit that goes through is a candidate to be deployed. So that's our build pipeline. In reality, it's often more complicated. The build pipeline could be a graph, not a list of sequential steps, but that's certainly a way you can get started. Start out sequentially, and then as you become more sophisticated, you will probably have some steps that will run in parallel. You will have some fan out and some fan in later on in the pipeline. And we build quality in at each step. We define some quality gates, for example, our tests or automated code checks. And if a commit doesn't pass these checks, then we stop it and say, hey, this one is not fit for release. We give the developer quick feedback so that in the next commit, he can fix this and we'll get a commit that's better, that travels further down the pipeline. So a little bit more concretely, typically the pipeline starts with checking out from version control. So for example, Git. And then one of the first steps will be to compile our code and unit test our code. That's really our first level of control. So if it doesn't compile or if the unit tests fail, then the commit is certainly not good to be released. After that, next step could be to run some higher level tests, some integration tests, or for example, integration tests typically already have some external dependencies. For example, they might use a real database or a file system. Next step could be we could run some code analysis, some static code analysis, and we'll talk a little bit about that later. And then at some point, we are ready to package our application, for example, package it into a WAR and deploy it into some environment. So there could be typical environments, not just, there could be multiple environments, not just production, but we could also have a test environment and a UAT environment, and of course we'll also have a production environment. And the next level of tests, our acceptance tests, these are the tests that test our code from outside, from a user's perspective. They typically need to be deployed in such an environment. So we want a test environment that's as close as possible to the production environment, and that's where we're going to run our acceptance tests. So that's our third category of tests after unit tests and integration tests in this pipeline. And as I said, there will be other deployment goals, other environments. Perhaps you have some user acceptance testing. There could be a manual phase here. There could be some manual testing involved here. And at some point, you're going to deploy into production. OK, so that's very nice. That's a theory. You can get much more information on that in Jez Humble's book, Continuous Delivery. So if I can wholeheartedly recommend that book. There's a lot of information, but still the question stands, how do you implement it? Which tools do you choose, and how do you really go about implementing such a pipeline? And this is what I'll focus on in the rest of this talk. So I'll give you one example how you can build out such a pipeline with Jenkins and Gradle. OK, so we need an application that we want to ship, that we want to deliver continuously. And so we've chosen this revolutionary sample application, a to-do list. And we'll think, that will rock the world, and we'll get a lot of VC for this revolutionary application, but only if we can ship it really continuously and push out tens of releases per day. So we need to do some automation around that. It's a simple web-based application where from the browser I can interact with my to-do application, and then the to-do application writes to some data store where it stores my to-dos and stores their status. That's all there is to our revolutionary sample to-do application. OK, now at a high level, if we look at this from a high level, we could say we have three architectural parts here. We have a web layer, we have a model layer, and then we have a repository where we're going to store our to-do list. And there are some dependencies between these components. So obviously, both web and repository share the model, and the web layer accesses the repository to fetch and store the information. Now, how could we model that in Gradle? Here is a directory structure as you would check it out from version control. And a good general guideline is to structure your build, your directory structure after the high-level architecture of your project. That's not a must, and you can start even smaller with just a single source tree. But in general, if you're unsure, I often start with like 3 subprojects for my 3 layers, if there's a clear layering in my architecture. So something between 1 and 5 at most is what I would typically start with. Be careful, don't do it too fine-grained. Too fine-grained is as bad as monolith. I think the current world record for Gradle build stands at about 3,000 subprojects. Don't do it. Unless you want, you want to beat the world record, of course. Okay, so this would be a typical directory structure for a to-do application. I have 3 subdirectories for my 3 layers. Each of them has its own Gradle build script, and by default, the name of a Gradle build script is build.gradle. Then a build will also contain a Gradle directory, and in that Gradle directory, we'll typically find 2 things. We'll find additional build scripts, and I'll talk about them in a second, and we'll find the Gradle wrapper. The Gradle wrapper, that's a very neat way to bootstrap Gradle installation. So who of the Gradle users in the room are using the Gradle? Who's not using the Gradle wrapper? Using Gradle, not using the wrapper? Okay. So you should really look into the Gradle wrapper. That's a very nice way to bootstrap your Gradle application. It works this way. You can type Gradle wrapper on the command line, and it will generate a few files that you then commit to source control. It will generate a bat script for Windows and a shell script for Unix and Mac. And then you will run Gradle always via this shell script. So you no longer locally install it and put it on your path, but you always everyone always runs one of these scripts. And what these scripts do, this Gradle wrapper command also generates a small bootstrap jar, like 10 kilobyte jar, into the wrapper directory. And this shell script will then call into that bootstrap jar, and that bootstrap jar will download Gradle. And where will it download it from? By default, it will download it from servicesgradle.org, but there is also a properties file in here, so you have full control over where Gradle downloads it from. So for example, in your enterprise, if you already have a binary repository like Artifactory, it's very common to put Gradle installations there and then adapt the properties file once, check it into source control, and the Gradle installation problem is solved for everyone once and forever. So this has 2 advantages. Nobody has to install Gradle anymore, which includes your CI server. So no matter how many agents you have, you never have to install anything there manually, which helps a lot. And the Gradle version that everyone's using is now under source control because it's in this properties file. So everyone will always be using the same Gradle version. And once you are ready to update to the next Gradle version, all you're going to do is to change the URL in that properties file, bump the Gradle version, and with the next build, everyone's on the next version. So everyone will be always on the same version. It's very easy to bump everyone to the next Gradle version. So that's the Gradle wrapper. What else do we have? We have an overall build.gradle, that's a root build.gradle, and we have a settings Gradle that holds everything together. I'm already getting ahead here. So in the subproject build.gradles, we define the things that are special to these subprojects that only hold for those subprojects. That's a common pattern. Again, Gradle is very flexible, but I'm showing you one common way to do it. And in the build.gradle, you define the things that hold for all subprojects, and the settings Gradle is the glue that holds it all together. So this is what we call a Gradle multi-project build. This is the root project, and we have 3 subprojects, so a total of four projects in that Gradle multi-project build. And the settings Gradle is what holds it together, and it tells Gradle we have 3 subprojects here. So you always have, each Gradle build has at least one project, which we call the root project, which corresponds to this outermost build.gradle. And then we have 3 more subprojects here, which we can include with this include statement inside settings Gradle. And there are more configuration options here. For example, it can be convenient, as you get more subprojects, it can get convenient to not call all of them build.gradle, but it would perhaps be nice to call this one model Gradle and this one repository Gradle, because once you have like 10 subprojects and you open them in a tabbed editor and all of them are named build.gradle, that's not very helpful. So these are the kind of things that you can also configure in the settings Gradle. So give those build.gradles, these files, different names. But as a start, a simple settings Gradle that just has a few include statements is good enough. Okay, I already talked about the Gradle wrapper, a very good way to bootstrap Gradle installations, and I highly recommend that you always use the Gradle wrapper. It's also really great for open source projects, because the first question you have when you want to contribute to an open source project, oh my gosh, how do I build this thing? What do I need to install? And with the Gradle wrapper, that doesn't exist. The README of the open source project says type Gradle w build, done. So it's a really nice way to bootstrap Gradle. Yes, and there's one more thing. There are these additional Gradle scripts that you, by convention, they go into the Gradle directory. Again, that's just a convention. And this is where you can factor out things that are concerns of their own. So examples would be integration testing. If you want to set up your integration testing, then it's very common to have a file here called integration-test.gradle. And the idea is simply that your build.gradles don't get too large. We try to view them as, handle them in the same way as our production code. So we try to keep them dry and try to keep them readable and small. And as soon as something gets too large, we tend to factor it out into an additional Gradle build script, which you can name to your liking. And then you can include it in one or more of the main build.gradles. So typical examples would be you could implement your own versioning strategy. You could set up integration tests or acceptance tests. Your deployment, that typically requires a bit more setup. And even if you only include it in one build.gradle, it's a good practice to factor it out, give it a nice name, makes the build easier to understand. Okay, so what will we get out of this Gradle multi-project build? As I said, we have 4 projects, the root and the 3 sub-projects. Model and repository, in this case, will build a jar, and web will build our final war. So we have 3 artifacts, but eventually we are only going to ship the war. So that's our deployable artifact. Okay, so now let's have a look at our build pipeline. We'll further divide our pipeline in several stages, and the first one is called the commit stage. And the purpose of the commit stage is to assert that the system works at a technical level. We already had a quick look at this stage, so it starts with compiling our code and running our unit tests. Then we move on to higher level tests, integration tests that maybe already talk to a database. Then we run some static code analysis. Once we are happy that the system works well on a technical level from an inside perspective, we then create our war, and then we publish it to a binary repository such as Artifactory or bin tray. So that would be our commit stage. And an important concept is that we build our binaries just once. So at the end of the commit stage, we have our binaries. In this case, it's just one. And from then on, we are going to send that binary further down the pipeline. We are not going to rebuild it. We keep it, and so this makes sure that what travels through the pipeline and pops out at the end is really the same thing. Because what you want to avoid is that you test one thing, then add some, I need to add some more SQL scripts to my war and some properties files, and then what you ship is completely different from what you tested. That's what you want to avoid. So you build it once, and you test it and deploy it. It always stays the same. So the second stage, first of all, has to retrieve the binary that the commit stage pushed. Let's say it pushed it to Artifactory. So this one pulls it from Artifactory, then deploys it into a testing environment, and then runs our acceptance tests. That would be our second stage. And this stage would assert that the system works on a functional level, or we could also add some non-functional tests. We could, for example, do some load or performance testing there. And in this pipeline, we have 2 more stages. We have some user acceptance testing that's manual in this part. So we deploy into a user acceptance testing environment where a testing team can have another look at it and maybe do some exploratory testing, things that are hard to catch with automated testing. Of course, we don't necessarily have to do that, but it's entirely possible to have a manual step in the pipeline. And finally, once UAT is happy, we deploy the same binary that we built in the commit stage into production. And you can see here the last 2 steps, they are triggered manually. So every binary, if it's good enough, it travels until here. It stops here after it passed the functional tests. And then the UAT team, they pull. Because typically you will produce a lot of, you have a lot of commits. ideally each commit travels through until here, so UAT will not be able to test all of these binaries you produce. So we don't want to deploy all of them to UAT, but we give them the opportunity to pick and choose whenever they are ready. So that's a pull model. They pull what they want rather than we push it on them. And Jenkins actually gives you a nice way to do that. So you can have a Jenkins dashboard where everyone can pull, where UAT can pull, and where the person responsible for release can also pull into the release environment. Is there a question? So the question is, in Gradle, if something fails, if you can make it fail all the downstream builds. So in this pipeline here, how we are going to implement it is that we are going to implement each step with Gradle and then all glue it together in Jenkins. And so Jenkins will trigger the next downstream step and will stop as soon as one of the steps fails. That's how we are going to do it. One more question?
How do you manage the environment level configurations if you have multiple environments?
Yeah, so the question is, how do you manage the environment configuration, because we have these different environments which probably need different configuration, and we'll get to that quite soon. Okay, so this is the build pipeline that we want to build. So let's take a little bit of a closer look at the first stage, the commit stage. Generally, there's the guideline that it should run in 5 to 10 minutes. Ideally, not just compile and unit tests, perhaps even the whole commit stage. So it's really about rapid feedback. It's our inner level most inner level of feedback, and so we want to tell developers really quickly if it's not good. So we need to keep this really, really fast. And we will run it on every check-in. And as soon as something's read here, as soon as a commit does not go through, it should be the highest priority of the development team to fix that. That must be their highest priority. We can include some longer running tests in the integration test phase. In that case, maybe we cannot do 5 minutes for the whole commit stage, but the longest running tests, they should come at a later time, for example, as part of our functional acceptance test suite. Typically, the integration tests differ from the unit tests in that they already require some environment setup, and we'll have an example how you could set up integration tests that work with a database. And typically, they're also harder to maintain because there are simply more moving parts. That's why they are called integration tests, which in general makes them harder to maintain than unit tests, harder to keep stable. So what's a good pattern here? Again, Gradle is a very flexible tool, but something we see very often, and what I would recommend is that you have different source trees for your unit tests and for your integration tests. So here we are in the repository subproject. And by default, Gradle follows the Maven directory structure. So your production code would go into source main Java, the unit tests into source test Java, and in this case, we put the integration test into source integ test Java. Now, that's all configurable in Gradle. You can do anything. You can do the sun pattern of source and test. You can really do anything. But that's kind of a good pattern that many teams follow. So again, you might start out with just a test and put both your unit tests and integration tests in there. And as soon as that runs longer than a few minutes, you might want to split it out because that's the easiest way to run just unit tests or just integration tests or both. Okay, so how would you do that? In Gradle with the Java plugin, you already get the production code and the unit tests for free. So you don't have to do anything except apply plugin Java. But for the integration test, a little bit of configuration is necessary if you want to have a separate source tree for your integration tests and a separate task to run just your integration tests. And this is how it could look like. So there are essentially two things to configure. There is this source directory to configure. And in Gradle, that's called a source set. So a source set is a set of sources that logically belong together, like your production code, your unit test code, or your integration test code, and some additional information. In particular, each source set has one or more source directories, in this case for Java, one or more resource directories, and it has a compile class path and a runtime class path. So that's really modeled after the JVM world, I would say. And this is how you could set it up. We set our Java source directory. We only need a single one. Set it to source integration test Java. We have a separate resource directory, source test resources. And then the compile class path and the runtime class path. You can find all of that in the Gradle user guide. There are lots of samples included in the Gradle user guide, more than 100 samples. Actually, they are contained in the full Gradle distribution. So you can find that there. And what do we do here? We say our compile class path, that's our production code. So that's the output of the main source set. That's the compiled production code. Plus, in this case, all our test dependencies. We don't make a distinction here between compile time and runtime. We just want to have all of them on the compile class path of our integration test task. And the runtime class path of our integration test. So when we run the integration tests, what do we want to have on the class path? Everything that we already have on the compile class path, plus the output of the compiled integration tests. So that's how you would set it up manually. But just look at one of the samples in the full Gradle distribution, you'll find it there. And the second piece we need is we need another test task. So that would be a task, we call it integration test of type test. And there are also a few things you can set up there, like probably the most important here is the class path. So the class path for running your tests is exactly this guy here that we configured here, and we just reference it down there, SourceSets.integrationTest.runtime class path. That's exactly this. That's how you set up your integration test task. And once you've done this, you can run Gradle W. We use the Gradle wrapper, Gradle W integration test, and it will run your integration tests. And what this also gives you is that you can manage your external dependencies for integration tests separately from those of production code and unit tests. Because typically, integration tests, you will have more external dependencies. Maybe you want to bring up an in-memory database, or you want to bring up a web server on your local box for your integration tests. So typically, the integration tests will have more dependencies than your unit tests, and also dependencies that you don't want to ship. And so if you do it this way, have a separate source set, then you can also declare separate dependencies just for your integration tests. Okay, now let's say our integration tests use a database. Then we need to do a little bit more automation, and in particular, we need to start the database. Unless we are using a database somewhere else, but it's quite common to have the build start up a database for the purpose of integration tests. We need to make sure that we have the right schema, that our schema version that our application expects, and we probably have to tear down the database after our integration tests have run. Now, there are various ways to do that. If you're starting fresh, or if you are eager to change, there are two quite handy open source tools in the Java world, which are Liquibase and Flyway. And these tools give you a way to write incremental scripts that, when every time you make a schema change, you write a little script that just performs that change. And then you store the database schema version in the database, and you also store the application's expected schema version in the application. And then these tools will, every time you start up the application, they will compare the application's schema version and the database schema version. And if there is a delta, it will apply these incremental scripts that you wrote. So to either upgrade the database to a later schema version, or you can even, if you provide the reverse steps, then it can even downgrade the schema version. So if you have a new project, look into Liquibase and Flyway. Of course, if you have a legacy project, that may not always be an option because you may already have lots of automation around your SQL scripts. But these are nice tools to get started and take the next step with automated schema migration. Here's how you could do it. I don't show the tools in here, but you would typically refactor that into its own build script again, because this is one concern, how to set up your database. And then you want that to run before your integration tests. So what you say is integration test, the task depends on the start and prepare database task, and that task would be defined in the database setup. So this would go into the Gradle directory, and with apply from, that's just an include. You can include that build script right here. It's logically the same as copy and pasting it over. And so the assumption is that this database setup script gives you a start and prepare database task. And so we add this dependency to make sure it always runs before our integration tests run. And then how do we tear down the database? Depends on is not the only task relationship in Gradle. There are several others. And one of these other ones is finalized by. So we say that stop database is a finalizer task for integration test. And that means Gradle will always run stop database after integration test, even if integration test has failed. By default, if you're familiar with Gradle, Gradle will stop a build as soon as the first task fails. There are ways to force it to continue, but the default behavior is to stop immediately. But of course, you don't want that here because no matter if your integration tests failed or not, you always want to stop your database. And that's where this finalized by comes in. It's like a try-catch block in Java, basically. So this would be the finally here, try finally. And then Gradle has this generic check task, which typically runs all your tests and all your code analysis. So it's if you want to have the integration tests run when you type Gradle build, then the right way to do is to make check depend on integration test. The dependency chain is as follows. Build depends on check, among other things, and check then depends on all the different test tasks and all the code analysis tasks, everything that is about code quality, basically. That's the convention again. So if you make check depend on integration test, then Gradle build will also run your integration tests, if that's what you want. Okay, let's move on a little bit to code analysis. So one question to answer is if you want to measure your code coverage, so how much of your code is covered by your tests. There are a lot of tools on the market. So there is Cobertura, there is Emma, talking about the Java JVM world, there is Clover, and there is JaCoCo. And all of them have a little twist in how they do, how they measure code coverage. The difficult step here is all of these tools need to instrument your production code because they need to measure, the calls from your test code into your production code. So what they do is they instrument the production code, and they do it in different ways. So Cobertura typically does it with offline bytecode instrumentation. So you will add another task after compile that then instruments the compiled code, your class files. The challenge here is you don't want to ship the instrumented class files. You need to make very sure that you don't ship the instrumented class files, but the original ones. Emma also does offline bytecode instrumentation. Clover takes a different route. It instruments your source code. So it goes into your source code and adds source code there before you compile it, so that it allows it to measure the calls from your test code into your production code. And then JaCoCo does on-the-fly bytecode instrumentation. So it never touches source files or class files on disk. It does it in a running JVM. So as the classes get loaded, it instruments them on the fly in the JVM. And that's very nice because you don't have to set up anything, any additional tasks before or after compilation. And you can never ship that code because it never exists on disk. It only exists in the JVM that's running your tests. And that's one of the reasons why JaCoCo is the default choice in Gradle in the sense that Gradle already ships with the JaCoCo plugin. We don't ship with plugins for the other tools, but for most, if not all for them, I believe all of them, there are third-party plugins. So if you prefer one of the other tools, look for the third-party plugins. If you prefer with JaCoCo or are just getting started, then give JaCoCo a try. It's the easiest to get started with because it ships with Gradle and it's tested really well and documented. So nice thing is it doesn't modify either your source code or your bytecode. So how would you do that? You just apply the JaCoCo plugin. That already takes care of the instrumentation. You don't have to do anything. The only thing you have to add on top of applying the JaCoCo plugin, you have to configure the test report that you want to have. Because you might want to merge multiple code coverage measurements into a single report. You might want to have one for your whole build or one for each test task. And that's why the plugin leaves that for you to configure. Actually, for your unit tests, you already get it for free. But in this case, we also want to measure code coverage for an integration test. Whether that makes sense or not, that's a separate discussion. But let's assume we also want to measure code coverage for our integration tests. So we set up another task of type JaCoCo report. We tell it the code that we want to measure is our production code that's SourceSets.main. And the task that's going to trigger the measurement is the integration test task. So that's what it needs to know. And with that, we can run our tests and our integration tests. They are instrumented, and they will generate these files. They will generate some binary files which contain the measured code coverage, the code coverage results. And then what's left is to translate that into a nice report. And that's what the reporting tasks are for. So the measurements will already be produced by the regular test tasks. And then you need to turn those into HTML reports by way of these JaCoCo report tasks, like this one here. And this is the kind of report that you get out of this. So you can drill down in your code base, packages, classes. So here we are in the in-memory to-do repository class, and we see all the different methods, and we see some instruction or line coverage, and we see some branch coverage. So a very fine-grained report that shows you how well your production code is covered by your test code. This one?
This also requires a source set. So you say SourceSets.main means JaCoCo report main? Or is it referring to the SourceSets, the primary?
Yeah, it references the main source set. That's the source set that contains your production code. So that's the code that's going to be instrumented and measured. And it's going to be measured by the intake test task, because that's the, so it knows that when the integration test task, the intake test task runs, it's supposed to measure the production code. That's what it says.
I have one quick question. Is there a way for this tool to tell the minimum coverage that we want, for example, so that, I don't know, we want the task to fail with some coverage?
Yeah, so last time I looked at the JaCoCo plugin, it didn't have this quality gate. I'd have to check, maybe it's in there by now. In this particular pipeline, we implemented that on the Jenkins side. We are pragmatic, and sometimes we like to automate things on the Gradle side, but sometimes we automate things on the Jenkins side. And so in this particular case, you'll see we'll do that on the Jenkins side. So the question was whether we can have a quality gate here that tells us if the coverage is below a certain percentage, fail the build. That's exactly the kind of quality gates that we are looking for, right? We want to define ahead of time what's good enough to ship. And we want to have automatic checks that only make things travel further down the pipeline if those goals are met. And that's not just tests, that could also be code coverage or static code analysis. Okay, so we perform some health checks. We fail the build, the commit, if the quality is too low. And another thing that would be really nice is if we could compare the quality over time. If we could compare these metrics over time, so what was our code coverage like a month ago and what it is like today? Is it going up or down? This would be very nice to have. And I'll get to that in a minute. Before that, I'll show you some of the tools that ship with out-of-the-box support in Gradle. Again, we're talking about the JVM world here. Most of you are probably familiar with codes like PMD, find bugs, and check style, very common tools. JDepend if you want to define dependencies in your code. So, this layer can depend on that layer, but not the other way around. And then CodeNarc is a tool for Groovy. So it's kind of the check style and find bugs for Groovy. Typically, these tools work best when you use them for the language they were designed to work with, because they look for certain patterns in the code. For example, they know typical patterns in Java code. And if you then run the same tool on Scala code or Groovy code, you might get some false positives, because the tool might not like some code which is actually generated by the compiler, by the Groovy or Scala compiler. So in general, these tools are targeted to work best for a particular language. For example, there are other code coverage tools for Scala, and there is this find bugs and check style for Groovy. So keep that in mind if you use a language other than Java. So for each of them, we have a plugin. So for example, apply plugin PMD. You can then configure it further. Here it says don't fail the build if something with PMD goes wrong. I'm not a big fan of that. I'd rather just define a small set of rules and be very strict about them, because otherwise you run the risk of the broken window syndrome. I remember once we introduced on a project, like almost 10 years ago, we introduced this kind of checks on a legacy project, and then we wanted to really do a good job, and we spent a week defining all the rules, and then we had like 10,000 failures. And how do you get out of this? It's almost impossible. So then it became this broken window syndrome that nobody really cared, right? So I'm a big fan of limiting the set of rules that you check, but then fail the build immediately if you have one error. Some of the tools, they also allow you to define this is only a warning, and this is an error, and only fail the build on errors, this kind of thing. But in general, I recommend to be strict. These tools can generate different reports. So here we disable the XML report. That might be interesting for your CI server or for other downstream tools. They generally like the XML reports because they can parse them, make sense of them. And if you want a report for humans, of course, generally you would prefer the HTML report. It can pay off to turn off the reports that you don't need, especially the HTML reports, because if you use lots of tools, those HTML reports can take quite a while to generate. So if you don't use them, if nobody looks at them, because some downstream tool, maybe all of this is visualized in Jenkins, in your case, then turn off the reports that you don't need. And likewise for the other tools, it's very similar with all the tools. The nice thing about these integrations is that they don't ship with the specific version of the tool, but they are flexible enough to support a wide range of tool versions. So it's as simple as saying, I want to use JDepend 291, and it will automatically resolve that from a binary repository like JCenter or maybe Central, and all you have to tell it is which version you want. That's really nice. So you don't need a new Gradle release to upgrade to a new find bugs or check style. And if you want to run all of them together, you can run them with Gradle wcheck. If you want to run a single one, you can just type Gradle JDepend or Gradle PMD. Actually, there is a task per source set. So if you want, you can run find bugs also on your test sources and your integration test sources. And actually, that's something I typically do for my projects. I don't just check my production code, but I test all my code. I treat all my code the same, no matter whether it's production code or test code. I talked already before about it would be really nice to compare my metrics over time. And one way to do that is to use Sonar. By now, it's called Sonar Cube. So who of you is already using Sonar? Yeah, quite a lot of people, good. So that's the next step up from these individual tools. Sonar is a web-based code quality platform. And the way this works is we have first-class support. We ship with a Sonar plugin. Actually, we ship with 2 of them, and you should use the new one, the Sonar Runner plugin. So if you start today, don't use the Sonar plugin, but use the Sonar Runner plugin. And how does this work? The Sonar Runner plugin has a single task, Sonar Runner, and that analyzes your whole build at once. So there's not a single task per sub-project, but there's one task which analyzes the whole build and all of its code. And in the Gradle case, it can reuse some of the reports that these tools produce, most importantly, your test results. So Sonar Runner will not run your tests again. So you will run your tests in the usual Gradle way, like we've seen already with Gradle test or Gradle integration test. And then the Sonar Runner will pick up the XML JUnit reports and will include it into its web view. And it will run some of the other checks on its own. So it's quite heavyweight. It can run, if you have a large code base, it will take quite a while. And the general recommendation is don't run it with every commit. You can try it if you start small, but often large teams run that once per night. That would be a typical way to do it. On your CI server, once per night, CI server runs the Sonar Runner task. The results get published into the Sonar database. And the Sonar web application then reads and writes from that database and gives you a nice view on all your metrics over time.
Run once per night, and that is part of your quality game. How do you get multiple reports to problem?
Yeah, that's a good question. If you run the if you run this tool once per night, then it's not part of the quality gates of your pipeline. So in that case, it's not perfect, right? It's always a trade-off. You can run it with every pipeline, but it can become a performance bottleneck, so it's a trade-off. You could also, in your pipeline, just run the Gradle individual tasks, which are typically faster, maybe just a small subset, and then overnight, you run a bigger suite that also collects the metrics over time. So it gives you some additional information, oh, my code coverage is dropping, maybe I need to invest more into testing, some things like that. So there are different options there. Here's an example of how you configure it. You say apply plugin Sonar Runner. It has a simple property-based configuration language, so you configure it with a few properties. Most important is the database URL, the host and JDBC URL, and the credentials. Typically, credentials, you wouldn't put it right into the build script. We'll get to that. So you would typically externalize them and then just read them in here. And then you can also configure it further. It's quite smart by default. It configures lots of things because Gradle already knows lots of things about your build, right? It knows where all the sources are located, where the tests are located, which languages you use, and all of that, it feeds already into Sonar. So I would say maybe like 20, 30 properties it pre-configures automatically. Sonar wants to know about all your third-party dependencies and these kind of things. Everything's pre-configured. So typically, that's enough to get started. But if you need to configure it further, you can, in each sub-project, can again override some properties. And all of these properties are documented on the Sonar homepage. So this is not something we made up, but these are the official properties of the Sonar Runner tool, which you can look up on the SonarCube homepage. And then Gradle W Sonar Runner will run that, and typically only CI will run that. A developer will not run this. Okay, here's an example for the Sonar web view. That's what it looks like. So we have nothing there so far, and now let's play CI server and let's run a Gradle build. So we run Gradle W Sonar Runner as our CI server would. Gradle starts up, soon gets to the Sonar Runner task down there. And then Sonar Runner runs multiple tools under the hood, such as PMD and checkstyle. You can see some of them here in the output. And finally, it publishes to the database. So you can see it picked up any JaCoCo code coverage result. It runs PMD under the hood. It runs some of its own measurements. And after that, if we refresh the web view, we see now our to-do project here, the version lines of code. And now we can drill down. We can drill down and get a set of base metrics, lines of code, comments, duplication, how many rules are violated. You can configure, you would configure in the web application which rules you are interested in. Some complexity measures, and nice thing is that you can always drill down into individual packages, classes, and even methods. So 37 violations. Let's have a look at the violations for this class. Our to-do repository built on top of H2. So apparently we are not closing some resources. It also gives you all your source code. So it sucks in all of this information and presents it in a nice way. We don't have a whole lot of coverage, so probably we need to do something there. For this one class, we have like 97%, which is really good, if it's true. And we can configure what exactly we want to see here. So in this particular case, since we measure code coverage for integration tests separately from unit tests, we can add another widget that tells us what the code coverage is for our integration tests compared to the overall coverage and the unit test coverage. So the view can be configured to our liking. And here we can see which code is not covered, which is quite a lot. So we probably have some work to do here. And as I said, I'm not showing it here, but you also get this nice time machine set up so you can travel back in time and then compare how were things a week ago and how are things today. And that really adds value over just producing a new report with every build. Okay, so much for code analysis. Now we're getting close to the end of our commit stage. We need to assemble our war and publish it to a binary repository such as Artifactory. A few things here. What exactly do we include in our binary except the code? There's always the question, do we include or exclude the environment configuration that we need if you need to deploy it in different environments? The most important thing is that you only build the binary once. So if you want to include environment configuration, you need to include it so that it works for all environments. We don't want to repackage it later, oh, now UAT needs this other stuff in the war, and production needs this other stuff. That's what we want to avoid. So a good guideline is don't include environment configuration, solve that with some other configuration management tool perhaps, but always include some build information. That's really handy. Like, for example, the git char, so which commit produced that binary, or what was the build date, which version, this kind of metadata. It's very, very helpful if you put that inside the artifact, because that allows you to trace, for example, an issue in production or UAT back to the commit, for example. So it's always a good idea to include the build information. In terms of versioning strategy, there's the Maven way where you develop towards 1.0, so you have 1.0 snapshot. And then once you're getting ready to release, you use something like the Maven release plugin, which will bump the version to 1.0, commit it, deploy it to the binary repository, and then bump it again to 1.1 snapshot. The thing is, for our continuous delivery, that's not very good because every commit could go into release. So when do we make the switch between snapshot and release artifact? So it's more common to have a more continuous version strategy. And one example is this one, a simple example. You have a version number composed of 3 parts, major, minor, and then you have a running number. And that running number is bumped with every commit. In our case, the major and minor, that's under our control. So we have to bump that explicitly in the build script. So perhaps we follow a semantic versioning semantic, so that for a new feature, a non-breaking change, we would bump the minor, and for a breaking change, we would bump the major. And the last number we leave up to Jenkins to bump it for us with every single commit. And so we don't have to store this in version control because this would give us a lot of commits. Like for every commit, we would get another commit that just bumps the version number. And this we can avoid by storing the build number in an external system such as Jenkins. In terms of versioning strategy, here's an example again how you could factor that out into your own build script, versioning.gradle, that we then apply to all our projects. All projects should follow that versioning strategy. And here we implemented a simple version strategy ourselves, a simple Java Pojo. Actually, it's Groovy. It's in a versioning.gradle build script, but you can put a Groovy class in there. And it has these 3 components I talked about, major, minor, and build. The major, minor we manage here manually in this case. And the build environment we read from an environment variable. So this is how it's going to work. Jenkins is going to persist this number. With every Jenkins build, it will bump it and then pass it to our Gradle build via an environment variable. That's a simple way to communicate between Jenkins and Gradle. And so this just stores the 3 parts and then has a nice toString. And actually, we can assign that to the Gradle version property. The Gradle version property, every project in Gradle has a version. And that takes any object, and it just has to have a toString. So when Gradle always uses only the string version of that, so you can have your own Pojo. As long as it prints a sensible toString, you can model your version in any way you like. Perhaps in the future, Gradle will ship with some of these implementations on its own. Would be nice if Gradle already shipped with the semantic version, for example, but currently it doesn't. And you either can pass just a string to that version property or any Pojo that produces a string eventually. So this is where our Jenkins build number will come in. I talked about this metadata that we want to include in our war. So this is how we could do it. We create a little task. We call it create build info file. And all it does, it creates this properties file, build info.properties, a simple properties object, and then stuffs in a few things that might be of interest. So here it adds the version as a property. It adds a timestamp. A git char would also be a really good candidate here. So a simple task that writes this properties file, and then we need to include that in our war in this case. And so we need to configure the war task. First, we make it depend on this task that creates the build info properties. And then this is the syntax in a war task, or more generally a Gradle copy task, how you can include additional information in your war. So you just say, we write this build info properties right into our build directory. So we copy from the build directory, but include just this build info properties, and we copy into webinf classes so that our web app can then easily read that properties file.
Would you ever use the build info plugin for Gradle?
You mean the Artifactory one, or? There is a build info plugin. You're right. I'm not exactly sure if it serves the same use case. So maybe let's have a look at the end of the talk. It really depends on what you want to include. There's also, if you happen to use Artifactory, there's also a great plugin by JFrog, which packages up a whole lot more information and publishes in a way to Artifactory so that Artifactory can make sense of it. So it publishes it as JSON that Artifactory understands, and that gives you a lot of traceability inside Artifactory. Then Artifactory is aware of your builds and your projects and their dependencies and so on. So that's a really good choice if you happen to use Artifactory. Here we implemented our own thing, and in any case, we also want to have some of this information at least in our running web application. Okay, so now we've packaged our war. Last step of the commit stage, we want to publish it to Artifactory. And we have this nice continuous versioning strategy, so we already have 32 and 33 there, and now next time, end of the commit stage, we are going to publish 1034 to Artifactory. How could you set that up? Here, you could either configure the Maven publish plugin, that's what it's called directly, or you could be a little bit more abstract and collect a few keys and properties here, perhaps also ones that change per environment, and put them in their separate file. So in this case, we use a class called Groovy config slurper. That's a nice way you can write a file with Groovy syntax, but it just becomes a glorified map. So it's basically the same as passing JSON. That's kind of JSON in Groovy syntax. So you'll get a map of maps out of that with string keys and values. And the nice thing about this config slurper class is that it has built-in support for environments, which relates to the question we had before. So config slurper has built-in support for environments. So you can say I have a test environment and I have a UAT environment, and both of them have a server, but it's a different server running on a different port and with different credentials. So this built-in support for environments, the information that's the same for all environments, our binary repository that we declare on the top, and the rest we declare under the environments block. That's just one way. You could also implement something similar in Gradle build scripts. But in this case, we chose to use config slurper to show off some of Groovy's built-in functionality. And the credentials, typically you never hard-code them. An easy way is to put them into an init.gradle in the Gradle user home. So somewhere under userhome.gradle, init Gradle, only on CI, for example, you put that file. And then you can very easily just refer to it's a properties file, and you can just refer to those properties from in here without any additional effort. So they immediately become available. And that's a way how you can have properties which are specific per operating system user. So that's one way to deal with credentials. What else? So now we have this file, that's a Groovy file, and now we need to evaluate it so that we get this map of maps, that we get the information which we can then use in all our Gradle build scripts. So how could this look like? At the top of our root build script, it's part of configuring the build. We add a little bit of code that allows us to read this config file using the Groovy config slurper class, and we pass an environment. in this environment, we read from the Gradle build. So we look for a property called environment in the Gradle build script or passed from the command line, and that we pass on to the config slurper, and that will get us the information for the current environment. So if we then run the build with and pass test as our environment, we'll get this information. We can in our build scripts, and if we run the test with UAT as run the build with UAT as our environment, we'll get out these properties. So this is how we are going to invoke it then. So the different Jenkins jobs will, depending on which environment they want, they will pass the environment as a command line argument. -p_env, that corresponds to this property env that we are reading here, and then we pass one of UAT test or prod. That's one way to do it. Okay, now we need to tell Gradle that it should publish to Artifactory. You would use the Maven Publish plugin for that. I don't want to delve into the details. It's not very interesting. You need to tell it what to publish and where to publish. So this would be our Artifactory, for example, or Nexus, any Maven or Ivy repository. And this is the what. And we say we have one publication. We call it web app. It's a Maven publication, so we publish to a Maven repository. Could also publish to an Ivy repository. And what we want to publish is a web component, in other words, a war. So Gradle has built-in support for a few different kinds of components, and it knows what a war is. It knows that a war already includes its dependencies, so it doesn't have to publish the dependencies separately, and so on. So that's the way to publish a war. And you can read more about this in the Gradle user guide. Yes?
Just to be clear, the environment configuration is packaged as part of the war?
Can you say it again?
Just to be clear, the environment configuration is packaged as part of the war?
No, in this case not. So here, in terms of environment, we have just different configuration properties for each environment. Like we need to deploy to a different host, for example. And all the environments are modeled in our Groovy script in this example here. And then what happens is that by default, we always use the test environment because that's probably the one we're going to use locally. And if someone, typically Jenkins, passes in -p_env equals something else, then we'll use the information, for example, the host information for that particular environment. So that's one way to string these things together and to get your different properties for different environments. Okay, and finally, the Jenkins build job will run Gradle w publish to publish our war, to build the war that's implied here, and then publish it to the Maven repository. Okay, so in this example, we're publishing to Artifactory. So let's have a look. We're publishing into this repository here, libs release local. So now we're playing build server again. So we are setting this environment variable that would usually be set by Jenkins. And then just to test it out, that's a good way to, while you're developing the build, you can test it out locally, all the individual steps. And then we run publish. So assemble builds the war and publishes it. Okay, successful. We see that we published this to-do web with the right version number, 33, to this remote repository. And now if we switch back to Artifactory and refresh it, we should see our war file appearing there. So it's a little bit small, but here's our to-do web, 1033, and here's the war file and the POM file. And then while we develop the build, we make sure we pretend we are CI, so we bump the version number as an environment variable, publish again, and now, of course, the next version should appear in Artifactory. So if we refresh again, we should see 1034 appear there. In Artifactory, we want it versioned. We want all of them there. Once you deploy it, you can always change the file name if you need to. It's not a problem. Yes, you can change the name if you want to.
Question. So if you're using the environments model, when you build, you have to build separate wars for your platforms, your environments, right?
No, we built just one war. We built just one war. In the commit stage is environment agnostic. And then we can deploy the same war into different environments. That's the model that we are following here. So we can deploy the same war into our test environment, into our UAT, and into our production. And those environments have different credentials and different hosts. And so that's the environment-specific information that we are managing here inside the build. So we manage test and...
So that environment information that you're managing in the build is picked up on runtime? It's not picked up...
It's picked up by the Gradle build that's called, there will be there's a Gradle task to deploy to each environment. So you can, and there will be one Jenkins job that calls the right Gradle task to deploy to test, another one that calls the right Gradle task to deploy to UAT, and another one that calls the right Gradle task to deploy to production. And we'll see the Jenkins setup in a minute. Okay, so now the next stage, our acceptance stage, where we want to run our functional tests. And as I said, we don't want to build our binary again. We already have it in Artifactory. So what we want to do now is pull the binary in, deploy it into our test environment, and then kick off our functional tests. That's the goal for our simple acceptance stage. So how could we do that? First, we need to pull it down from Artifactory. So we have these versions. So again, we have to know which version we are testing. That has to be provided to that Gradle build step. And then it will go on to that Gradle build step, will pull that version down, deploy it in the right environment, and then kick off a test suite. So first of all, how do we download in Gradle from a repository? We can use the regular Gradle dependency management to download the war file that we want to test from Artifactory. So here are details. We need to again provide that Maven repository. We already have stored the URL in a variable so that we can easily reuse. We do a regular dependency declaration on our own war. And then downloading in Gradle is as easy as copying. So we copy from this war configuration. That's a named class path. Think of it as a named class path that holds this war. And we just can give that to any copy task as the source. So we can not only copy from file system locations, but we can also copy from binary repository locations, just as easy. And we copy that war from Artifactory into a correct directory called download. So once we call that task, Gradle w download binary archive, it will pull the war from Artifactory. That's the first step. Then we need to deploy it, presumably into our web server that's running in the test environment. And here is where the environment variables come in, right? We could now deploy the same war file into test, UAT, or prod, depending on which environment variable we set. And for each of those variants, we'll have a Jenkins build job that deploys into that environment and passes this environment variable. So there are a number of ways to deploy into a web container. There are a number of third-party plugins. One of them is the Cargo plugin, which you might also be familiar with from Maven. There's also a Tomcat plugin, if you're specifically after Tomcat. It's another good plugin. And so you apply the Cargo plugin, and then you need to set up a few things. So which kind of container is it? Which port is it running on? What's the file to deploy? In which URL context do we want to deploy it? And where do we want to deploy it to? So credentials and hostname. And another thing that we want to do here is before we deploy, we try to undeploy the previous version if there is one. So that's also supported by the Cargo plugin. So if there's already a version deployed, you can undeploy them before you deploy the new version. And then we establish the necessary task dependencies. So before we deploy, we want to download the thing to deploy, and we want to undeploy the previous version if it exists. This corresponds to these task dependencies. Yes, and again, this is written in a way, this uses our config file that we used before, the config slurper. So the same build script works for all environments. The same build script can deploy into all three environments, because these variables here, they will contain environment-specific values that we defined in this Groovy build script where we said environments, test, UAT, and so on. So with Gradle W, Cargo deploy, and passing an environment, we now have a simple way to deploy into any of our three environments. So let's give that a try. So we are trying to deploy to Tomcat on our local box. So we don't have much there in the beginning. And again, that's a nice way to test it while you are developing the build. So first we concentrate on the individual build steps, and only once we have automated all steps in our pipeline, only then we take it to the Jenkins level. That's a question?
What if your deployment has to deploy seed data or anything like that? Like, do you have any plugins for that?
There are a lot of third-party plugins around that. There's not so much that currently ships with Gradle in the war support. I'd have to look specifically. So it's always a question also with your environment. Typically, maybe you will have a separate configuration management tool that, or you have something like a Docker container. So there are a lot of ways also to prepare your environment around that war file or container. So let's have a quick look. So we run that cargo deploy task. We pass the test environment. In this case, this is the environment for running our functional tests. And it deployed successfully. It didn't undeploy because there was nothing deployed. So the application was not already deployed. It recognized that, and so it didn't have to do anything in the undeploy step. We see it downloaded the file now from the war file that it needs to deploy, downloaded it into our download directory, and if we refresh Tomcat, it will hopefully appear there. Here's our to-do application. Deployed into our test environment, and here you see, or you cannot see it, but here we show the version information that we packaged in the properties file in the war, right? We packaged it in a way that we can easily read it and display it here. A very common thing to do. Don't have to tell you that. And so the deployment in our test environment was successful. We can use that for manual testing or for running our automated functional tests. Okay, so last thing in this stage is to run our functional tests. So these are tests from a user's perspective, right? We want to test from a user's perspective whether the application works. It's the outside view now, no longer the inside view that we have had with the unit and integration tests. How could that look like? At the end of the day, it will be another test task. So as presuming we have a JUnit or test and G-based solution, even for our functional tests, it will come down to another test task, and probably it will need some additional information. So here we are using JEP, a Groovy-based browser automation tool. So we script our browser. We play the human interacting with the browser, and then we check whether our web application returns the right results. So that's a Groovy-based library, which I can recommend. It's a Selenium on steroids, basically. It's called JEP. And here we set it up with a few things. You would test it with real-world browsers. You can also do that in the cloud. There's integration for that. But here we just test it with our local Firefox. That's how we drive our tests. And we set up, we have to tell it, of course, where our application is deployed. That's where, when JEP fires up the browser, this is where it will navigate to. And then we set up the JEP reports. And then we can write our tests with plain JUnit or test and G. And those tests will use the JEP library to script the browser. Of course, there's many ways to do this, but it could be as simple as this. And we set up a few more directories where our test outputs go. And again, the UL is environment specific, so we could even run these tests on prod if you have a need to, or if you want to do a quick smoke test after a release, we could run the same or a subset of our test suite on the prod environment as well. And we run them by calling functional test and passing the environment that we want to test. Okay, so now we've seen all the individual steps of our build pipeline, and we all implemented them with Gradle. Now the one thing is missing to glue them all together, and this is where Jenkins comes in. So in the remaining time, I'm going to show you how you could glue all these steps together in into one Jenkins build pipeline. So the basic idea is we model the pipeline, the steps in the pipeline as separate Jenkins jobs. So for our to-do application, we have a number of jobs here. So this would be this first commit and unit test would be correspond to the to-do initial Jenkins job. In this case, we set up these jobs manually. There are also ways to set up Jenkins in a scripted way. so that you can easily reproduce a Jenkins setup. But here we did it manually. We don't have that many steps at the moment. After that, we run the integration test still as part of the commit stage. What else do we have? We have the acceptance test that will be in the second stage. We have code quality, those code quality checks. We have those code quality checks that also run in the first stage. We have deploy jobs for the different environments. So this job will deploy into test. For the functional test, this will deploy into UAT. And we should also have one that deploys into production, this guy here. So apparently we haven't deployed into production yet. It's a new project. What else? We have some optional performance tests here that we can also run before we deploy into production. And that's about it for the steps we have in this pipeline. Okay, and so how does it start? This job, the very initial one, this listens to version control. That's how it gets kicked off. So only the initial one, every time you check in, Jenkins will kick off this initial build step. So this is the project setup for this initial guy. And we make use of a few Jenkins plugins here. One of them is the build name setup plugin that we can give each Gradle, each Jenkins build invocation a nice name so that we can trace it across the build jobs. So in particular, we want to have this running number in there. You see to do, and then we have 76, 70, 75, 74. And we'll use the same number for every Jenkins job as a commit travels down the pipeline. So that's how we can easily relate the different steps for the same commit. We also set up some other Jenkins plugins so that we can see our code coverage right on the Jenkins page, and we can also see our test results. And again, we can trace everything because with the build name setup plugin, all those results will be named in the same way with our running number. So code coverage setup. And the next step is we need to trigger the next step if this one succeeds. So this one is just about compilation and unit tests. If it succeeds, we want to trigger the next step. And the next step, if you remember in our pipeline, would be the integration tests. And this is where this plugin comes in, called the parameterized trigger plugin. And that allows you to trigger the next downstream Jenkins job. We also use the Gradle plugin, gives us a convenient way to have each build job invoke Gradle. We, of course, use the Gradle wrapper, so we don't have to ever install Gradle on Jenkins slaves. Gradle will bootstrap itself automatically. And the first one, this first build job just runs clean test, which corresponds to our compile code and run unit tests. So that's how we set up our first build job. We set up the build name setup plugin here with this pattern. Build number, this is the running number provided by Jenkins. And we say we want to this build job be named to do and then followed up with that build number. And so we'll get this running number here in the Jenkins build history. And this build number is an environment variable provided by Jenkins. Now, how do we trigger the next step, the integration tests? We configure this build job, this parameterized trigger plugin. We say the next job is to do intake tests only when this initial one was stable, so only when this succeeded. Otherwise, we want to stop right away, not good enough. And we pass down some context information, namely this build number. So we can, with this parameterized trigger plugin, that's why it's called parameterized, we can pass in context information down this build chain. And here we pass down our build number and store it into a new variable that we call source build number. We also use the clone workspace plugin. So only the first build job ever checks out from version control. And so how does this information travel down? Well, in this case, we use the clone workspace plugin, and every job clones the workspace and passes it down, in this case as a tar GC, to the next step. So even the code, we already compiled, even if we haven't packaged it yet, we only need to compile it once. And especially also, we need to also only check out the code once. So the whole workspace that's being built travels down the pipeline for every commit. And that's what we use the clone workspace plugin for. Here we take the easy route. We just archive the whole workspace, and only if the current job succeeded. We also set up the JaCoCo plugin. There was this question, how do we fail the build if we don't have enough coverage? In this case, we solved this on the Jenkins side. We point Jenkins to the, first of all, to the JUnit test results generated by Gradle so that we can view them on the Jenkins side as well. And we also set some quality gates for code coverage. And we say if we don't have a certain amount of coverage, then we fail this Jenkins job. And again, we say, okay, this commit is not fit for purpose. We have to do better, otherwise we won't ship it. So this is a quality gate. Typically, we try to implement the quality gate on the Gradle side, but we are pragmatic. In this case, JaCoCo plugin didn't provide that feature, and Jenkins did, so we implemented that quality gate on the Jenkins side. Then for the next one, for the integration tests, you see we no longer check out from source control, but we just clone the workspace. So we point it back to the workspace of the previous build job and say just use that workspace. Don't check out from version control. And again, use the same number. We pass down this source build number. And again, also this job should also name its invocations with the same pattern. And so that allows us to correlate the different jobs across the same commit. Last but not least, we use the build pipeline plugin. That gives us a nice visualization of the build line, of the pipeline, and allows us to watch each commit as it travels down the pipeline visually. That's one way to visualize that. In this case here, we are, this is a late step which deploys into UAT. So here an example how you set that up. You call cargo deploy remote, set the environment to UAT. And the special thing here is we are using the build pipeline plugin, and we are defining here that promotion to production is a manual step in our pipeline. So it's basically once QA or whoever is happy with the commit, then whoever is responsible for the releases can push a button on Jenkins, and only then we deploy into production. So while we try to write code in such a way that every commit is fit for release, we may not actually deploy everyone into release. That's up to the project manager, whether you really want to deploy every commit into production or not. So the build pipeline plugin allows us to set up some manual promotion steps, but it's really just a promotion, right? Everything is automated, but there needs to be like this manual approval, push the button. If we want that, the build pipeline plugin has us covered. So that's down there where we set up that manual step. And this is how it looks like. So this is, each commit is one row. And each commit travels from the first initial step, where it just compiles the code, down to here. Here is deploy into production. And what's green, that already passed. What's yellow, that's running. What's red, that failed. And blue is yet to be run. And so we see our goal is that everything should go until UAT. So it should always be green until here. Then that means all our commits are good enough to go to UAT. And here, the last two steps then are, in our case, manual promotion. Here we see we have a commit that's not very good, so it stopped very soon. So we really want to have green all the way to the right. So here's another example, a live example for the setup. We already talked about most of it, but we do have the time to have another look. So these are all our Jenkins jobs. And here is our pipeline. And now we're going to trigger a build and watch it travel to the very right. So here we have 3 commits here, which are pretty good. All of them are good enough to be deployed into UAT. And here you see the button. These are the manual steps where you can say, where UAT can say, okay, I'm ready. I want to pull this commit, this row into my UAT environment. You see here that we set up Jenkins to show code coverage and test results. You see here the next downstream job that will trigger after to do initial, there will come the integration tests. We already talked about that before. So the first job is the one that checks out from Git in our case. Only the first one checks out. It gets triggered on every commit to Git or every push. We set up our to-do naming pattern with the running number in there. We use the Gradle wrapper so that Every environment always uses the same Gradle version. We clone the workspace, so once we are done with the initial step, we zip up the whole workspace and ship it to the next job. And we set some quality gates here for our JaCoCo setup, so that if we don't have a certain amount of code coverage, then the build will fail very, very early on. And last but not least, we trigger the next step in the pipeline. So if this one passes, we trigger the integration tests and pass down some context information, such as the build number. So that's how we chain the Jenkins jobs together. Okay, one more. This is the second one, our integration tests. It has initial at the upstream. Downstream, it has, I believe, the code quality checks. Main difference is here, we no longer check out from version control. We just clone the we just copy the workspace from the previous step. We again set up our naming pattern for the build run. And now we have a different task, right? Each Jenkins job invokes a different Gradle step. This one, integration test, we set up the location of our tests. Now, if you have many pipelines, you might want to look into automating that. There are also ways to automate that setup so that you can easily, like, template-based, oh, I need another build job of that kind, and you just run a script that will set that up for you. But in this case, we did it manually. Okay, so that's the deploy into UAT. That's interesting. We pass the right environment, UAT, call the same task, no matter which environment we deploy into. And the interesting thing is we have this manual deployment step to production. So we say at this manual gate, only go from UAT to production if someone pushes the button in the Jenkins UI. Okay, and now let's kick off one build, last but not least. So we kick off a new build. Takes a few seconds. Now we see we're already running the first phase, commit and unit tests. Yellow means it's currently running. Should be soon finished. So that was good. So our commit travels further down the pipeline. So now we're running our integration tests. Hopefully that will show soon. So now we're running our integration tests, and hopefully we'll travel further down. And here we have another commit we already traveled down, and here we also have a performance test step that I didn't talk about. So that's another, here in this case, another step that's manually triggered, but that's not part of our main pipeline. The main part is this deploy UAT. So we manually deploy into UAT, and once that passes, then we get another button here to deploy into production. So once we've deployed into UAT, we get the option to further deploy into production. Okay, so that's everything I had to show. Thanks a lot for coming and for your attention. If you have any questions, I'm there for the rest of the week. Come visit me at the Gradleware booth. I'd be happy to talk to you. And other than that, I wish you a great rest of the conference. Thanks for coming, and goodbye.